Square roots. Now, a square root is, we can think of it as the opposite to the exponent 2, okay? So I'm just going to put an x squared. It's the opposite to a number squared. The square root is the opposite. It's going to give us whatever that natural number was that multiplied together to get our perfect square, or a square. That's what a square root represents. So if we have this square root symbol, which we see right here, okay, so it's, you might have seen it somewhat differently. It is this little kind of goes down, up, and then across. Looks a little bit like long division, which you might have seen in the past, but we're not going to use a long division symbol anymore. We're just going to use a square root. So square root is used to determine what number multiplied by itself gives a product of the number inside. Okay, so in order of operations, which we dealt with in the past there, a square root symbol is used the same. So it's used the same as a set of parentheses. So whatever's inside of the square root is going to be, we're going to think of it as a set of parentheses. So we solve whatever's inside first, and then we take the square root of that value. Okay, we've done a little bit of practice with this in the past when we did, or you may have done a little bit of practice in the past, but today we're going to look a little more at what are square roots. So let's calculate the square root of 9. Well, you'll notice here we have our square root symbol and we have a 9 underneath. Now there's no other operations we have to do at this point, so all we got to do is figure out what number multiplied by itself gives us 9. Now if you look at questions 1 and 2 that you solved on your assignment already, and you'll notice that 9 is a perfect square. 9 is the product of 3 times 3. Okay? So we don't need to worry about that second one. We just know that the square root of 9 is 3, because 3 times 3 is 9. Okay? If we have, and this was something that, or one of them that we had earlier there, the square root of 4. Okay, if we look prior, 2 times 2 is 4, so the square root of 4 is 2. The square root of 1, 1 times 1 is 1. Okay, and again, we can go over and over with these and determine if it's a perfect square, it's going to be a nice number. If it's not a perfect square, it's not going to be a nice number. It's going to be a decimal that never ends and never repeats. Okay, so it's not actually even a rational number, it's an irrational number. What we're going to be doing in this lesson and for the next couple lessons is just looking at these perfect squares. So we may be asked to figure out, is something a perfect square or not? If it is a perfect square, we're going to take the square root of it and determine what our answer is from that. Now we could also use some operations as well. And so when we deal with order of operations, we might have something like this. We'll notice the square root of 13 plus 3. Now remember, as I mentioned earlier, pretend that this is in brackets. Let's do 13 plus 3 first. So I'm going to leave the square root there. 13 plus 3 is 16. So this is just the square root of 16, which is the same as 4. Okay, so it's the square root of 16, which is the same as 4. We could also have where we need to do that set of parentheses first. 12 minus the square root of 25. The square root of 25. Okay, now if you look at your perfect squares, you'll recognize that 25 is 5 times 5. And so this answer is 5. And then we have 12 minus 5, which is just 7. So we can use square roots in our in order of operations as well. We just have to make sure that we do our square root with whatever's underneath first, and then take the square root of that answer, and then we can solve anything else that comes about there. All right, now on that note, questions 3 to 7. Okay, some will be looking at what is the square root of certain perfect squares. Reference questions 1 and 2 when you're doing that. So recognize that questions 1 and 2 are all of our perfect squares from the first 20 of them, from 1 to 400. Okay, for the course of this unit or these lessons, okay, the lesson 10, 11, and 12 that we're going to be going through, we're just going to be dealing with those first 20 perfect squares, so from 1 to 400. I won't give you anything bigger than that at this point. If there's anything bigger than that, we can use our calculators. But for the time being, I want you to use just those perfect squares that you got. So questions 3 to 7, and complete those using your perfect squares you found in 1 and 2.